Okay, this section is 7.8, and this is where we're going to be looking at applications or word problems, if you like, of these trigonometric ratios. And what we need to remember for the primary ratios anyway is SOHCAHTOA. Up to this point, we've been using x and y values and always drawing our reference angle with the x-axis. Now, when we draw diagrams of just a plain right triangle, we do not always have a Cartesian plane there, and therefore we don't always use the x and y relationship. So we use the SOHCAHTOA relationship, which reminds us that sine is opposite over hypotenuse. So if this is the angle that we're dealing with here, opposite over hypotenuse in a right triangle, cosine is adjacent over hypotenuse, and of course tangent is opposite over adjacent. Again, to recall what an opposite side is, it's the side that the angle that you're talking about opens up and encloses, or eats if you like, if you're thinking of grade 2 alligators. And if you're looking at the adjacent side, it's always the enclosed side or part of the angle that's not the hypotenuse. Okay, so that's how you remember it. So we're going to look at a specific example here to start with. A 6.80 meter ladder reaches 4.6 meters up a wall. Find the distance that the base is from the wall. Fairly simple question. Draw a picture, always. So here's our ladder on the wall. And we're going to need our calculator to find, or a table of values for our trig ratios, which is in the back of your textbook if you don't have a calculator. Okay, we're assuming that the ground and the wall are 90 degrees because they're level. So here's our wall. We know that this distance here is 4.60 meters. And this distance of the ladder is 6.80 meters. We want to find this value here. Let's call it x. So by trigonometric ratios, we can find out, well, firstly, we could probably do this one with Pythagorean theorem, but we're going to use trigonometric ratios. Let's find this angle here first, right? And then we'll work this out here. I should have added that in. What angle? I'll add that in so that we have to do it. What angle does the ladder make with the ground? Okay, so there we'll go. We'll just add that in because I want that to be part of what we're going to do in our example here. So let's do that first. So the angle, so it would be opposite over hypotenuse. Opposite over hypotenuse is sine. So sine theta is equal to opposite over hypotenuse. So in our case, that's simply 4.60 over 6.80. So sine theta gives us a decimal number, and I'm going to do it on a calculator here. I hope you can see my calculator when let me check my field of view here. So if I were going to do a calculator, 4.6 divided by 6.6. So I get decimal 6969, so forth. Okay, now in order to go sine to theta, you have to do a second function and convert it back into an angle here. So how you do that is you take your shift button, your second function sine that value, and I get 44 degrees. So that is my angle. Now if I wanted to find x value, I could do it one of two ways, Pythagorean theorem, or I could use another trig ratio. I'm going to just use Pythagorean theorem because it'll be quicker for us. So x squared is equal to the hypotenuse squared, which is 6.80 squared, minus the other side here squared, equals. Okay, so if I do that, 6.8 squared, so 6.8 squared, 46.24 minus 4.6 squared, 21.16. That's 25.08. And root that to get x. 5.01 meters, so we'll go 5.01 meters. So we can write a sentence saying that the angle with the ground is 44 degrees and the distance from the wall base to the base of the ladder is 5.01 meters. I'm going to skip that sketch because I'm running out of space there and do my next problem here. Okay, so in my second problem here, I have a similar question. I have a kite that's flown with an angle of 26 degrees of elevation. So let's draw that in here. And we have a right triangle. We'll assume that the ground is level. On level ground, I should have said there. And we know that 112 meters, I'll read it out in case you can't read the whole thing. A kite is flown at an angle of elevation of 26 degrees. If the length of the string is 112 meters, what is the distance the kite is above the ground, and what is the distance the flyer is from his kite, ground distance? So we want to find the ground distance x here and y here. So we can simply use two trigonometric ratios for that. So we know opposite over adjacent, that's sine 26, opposite over adjacent, opposite over hypotenuse is y over 112. So y then would be equal to 112 times sine 26. So again with the calculator, let me just make sure my field of view is good there. Calculator, we just take sine 26. If you don't have a calculator, you can look it up in the back of the book, and that's on page 254. So sine of 26 is a decimal number there, multiplied by 112. And let's go to three figures. So that's 49.1 meters is the height above the ground. Okay, so that would be that one. And then if we want to do the distance, it would be adjacent over a hypotenuse in this case, which is cosine 26. And that's adjacent over a hypotenuse. So similar type thing. So we take x is equal to cosine of 26 degrees times 112 meters. So we just take 26, making sure that your calculator is in degrees, not radians. That's very important in this case. Cosine of that times 112. So the distance would be 100.7 meters. So therefore, if we went to three figures there, because that's what we should do, it would be 101 meters. So therefore, the distance from the flyer to the from flyer to kite along the ground is equal to 101 meters. Okay, and that's a couple examples of word problems that you would get there in section 4.6. Or sorry, 7.8. I don't know why I said 4.6. So in our next areas, we're going to be looking at our final chapter in Math A30 that we probably will do. And that'll be the counting chapter that happens in chapter 6.